I know it seems obvious, but can you prove the statement? If A then B is logically equivalent as, if not B then not A. Hope you'll make a video about this. Sure. The idea right here is that we're trying to show that the contrapositive is logically equivalent as the original implication. This one-way arrow means that we have if P, which is the condition, then Q, which is the conclusion. This means logically equivalent, and this means not. The contrapositive says if not Q, then not P. And right here I'm using P and Q because these are the notations I used in the previous video. So the way that we are going to go about doing this is to use a truth table. Not only I will show you how to do that, but I will also show you how we can also use an or statement to make this logically equivalent too, which is really cool. But I'm going to help you understand this first. In math and logic, many times that we will have to turn a regular statement into an if-then statement. For example, right here I can tell you that I go play basketball every Sunday. Well, how would you turn that into an if-then statement? Pay attention to the word if or every because this sets a condition. Right here it says that if today is Sunday, then I will have to go play basketball. So this means the same as if it's Sunday, then I will go play basketball. So in this case right here, this is going to be our P because that's the condition. And what's going to happen is I will go play basketball, and this right here is precisely the Q. So this right here is our original implication, and now for its contrapositive, which says not Q implies not P. For this statement, it's going to be if I don't go play basketball, then what do we know? It's not Sunday. They are logically equivalent. But you have to be careful though. Right here, if it's not Sunday, then what conclusion can you draw? Nothing. If it's not Sunday, can I go play basketball? Yes. If it's not Sunday, do I have to play basketball? No, I can stay home. Now to show that they are logically equivalent, here is the truth table, and this is how I usually go about doing this. Let's look at this right here first. So I need P and Q, and for each statement, it's either true or false, so we will have a total of 4 rows. So either P is true, Q is true, or P is true, Q is false, or maybe P is false, and this is true, and then false, false. Okay, let's look at this right here. P implies Q. Now, this right here, we will have to interpret it as if P is true, Q is true, then the whole thing is true. It's like if today is Sunday and I do go play basketball, everybody happy, I'm not lying, it's true. Next, if P is true, Q is false, which is saying if it's Sunday, but I'm staying home, I'm not going to play basketball. Well, that's bad, right? That's false. So far, so good. The next two are trickier. If P is false and Q is true, which is going to say, if it's not Sunday, then I go play basketball. Is this okay? Technically, it's okay. This right here is true. The last one, if P is false and Q is also false, if it's not Sunday and I am not playing basketball, this is also okay. The idea here is that when we have an implication, if the condition is false, then it doesn't matter what the conclusion is, the final result right here, they will be true. That's the tricky part. Now let's look at the contrapositive version. So I will need not Q and not P. Not Q, I'm just going to negate this right here. So true becomes false, and false becomes true, and then false, and then true. Not P, I'm just going to have to negate that. So false, false, true, true. Now kind of just ignore this right here, because we're going to look at not Q implies not P. Remember, if the condition is false, then it doesn't matter what the conclusion is. the whole thing will be true. So false implies false. This is actually true. All right? Remember, I'm just looking at this right here. Next, if I have true implies false, that's bad. That's false. Next, if it's false and true, this right here, right? False implies true. This right here is true because the condition is false already. It doesn't really matter what this is. Lastly, true implies true. That is true. So as you can see, this has the same result as that. And in that case, we say these two are logically equivalent. Okay? Very cool. This is one of my favorite things when I was learning math, logic, and also proof writing. But there's one more thing I want to show you as a little bonus right here. So let's have a look. And that's the following. The truth is we don't need an implication. Both of them are logically equivalent as the following. I can say, nah, P, because that's exactly what we went over earlier, right? If the P is false, and the other one is, this right here means or. Right? This means or. Q. When we have an or statement, as long as one of them is true, then the whole thing is true. So let's have a look. I'm going to set up nah P here and also Q here. So for nah P, I'm just going to negate all that. We will have false, false, true, and true. For Q, I'm just going to copy that down. True, false, true, false. Now for this right here, we're talking about an or statement, nah P or Q. And here we go. We will have false or true. Well, this is true, so that makes the whole thing is true. So this right here is true. Next, false and false. When we have an or statement, the whole thing is false. When we have both of them are false, so this right here is false. Next, we have true or true. Of course, that's going to be true. Lastly, true or false. As long as one of them is true, the whole thing is true. So have a look. This right here is once again logically equivalent as the original. So of course, it's also original to the contrapositive. So they are all logically equivalent. I think this is really cool. What do you guys think? Okay, before we go, I have this for you. On the left-hand side, we have not P and Q. This means and. And on the right-hand side, we have not P and not Q. My question for you guys is that, are they logically equivalent? Why or why not? Well, think about it, and I will make a video on that next.